Hi students, today I am going to start second chapter, Polynomials. It's a very simple chapter because most of the concepts we are going to discuss in this chapter we already learned in class 9 mathematics. So let's get into the topics. There are four main topics we are going to discuss in this chapter. First one is zero of polynomials. This is also we have discussed in class 9. And graph of the polynomial, that is a new topic we are going to discuss. And relationship between zeros and coefficients of the polynomial, that is also a new topic. And division algorithm for polynomial, this is we have learned in class 9. That is how to divide a polynomial by another polynomial. Okay, but still we will discuss all these topics. In the first part I am going to discuss only these three topics, that is zero of polynomials, graph of polynomials, relationship between zeros and coefficient, division algorithm for polynomials I will discuss in the next part. Okay, so let's start with the zero of polynomial. What is the zero of the polynomial? A real number k is said to be a zero of a polynomial if p of k is equal to 0. For example, we can take p of x is equal to 5x square minus 6x minus 8, and let x is equal to 2. We are going to substitute the value of x as 2. So we get p of 2. Okay. Remember, regarding the classification and the basic ideas of polynomials, I am not going to discuss in this video because we already learned very well in class 9. So, okay, so just refer those things like what is linear polynomial, what is quadratic polynomial, what is cubic polynomial, and degree of polynomial, like that. Many terms we have already learned. Okay, so you just recall those things by yourself. Okay, so p of 2 is equal to 5 into 2 square. Instead of x, we are going to substitute as 2. So 2 square minus 6 into, here one more x is there, so 6 into 2, because x equal to 2 minus 8. That is equal to, what is 5 into 2 square? 5 into 2 square is equal to 20. 2 square is 4, 4 into 5 is equal to 20, minus 6 into 2 is equal to 12, minus 8. 20 minus 12 is equal to 8, 8 minus 8 is equal to 0. So here, since p of 2 is equal to 0, p of 2 is equal to 0, 2 is a 0 of 5x square minus 6x minus 8. That is very important. Clear? That means a real number k is said to be a 0 of a polynomial if p of k is equal to 0. That means when we substitute that value k in the place of x, then we have to get the entire polynomial as equal to 0. Next topic is graph of polynomial. In case of linear polynomial, the graph of linear polynomial, p of x equal to ax plus b. This is the general form of the linear polynomial, where a not equal to 0. Is a straight line. It is always a straight line. Because of this reason, it is called a linear polynomial. And what is the degree of the linear polynomial? Degree of linear polynomial is equal to, degree is equal to 1. Okay, next, quadratic polynomial. The shape of the graph of a quadratic polynomial, ax square plus bx plus c is a parabola. Okay, we will discuss in detail what is parabola, how it will be. And what is the degree of the polynomial? Here it is, degree of quadratic polynomial is 2. We already know that. Clear? Let's draw the graph of linear polynomial so that we will get a clear idea. So I am taking here, for example, that linear polynomial I am taking. Okay, Linear polynomial. For linear polynomial, graph will be, so I am taking an example, that is p of x equal to 2x plus 4. That is the value of y. Okay, and here it is x. When x equal to 1, we will get 2 into 1 plus 2 plus 4 is equal to 6. Y value will be 6. When x equal to minus 1, we will get the value is 2 minus 2 plus 4 is equal to 2. So 2 points we have got. So we already learned how to draw the graph of a linear equations. So by using the same concept, we can also draw the graph of linear polynomial. So we have a coordinate system. I have drawn 2 axes, and let's mark the values 1, 2, 3, 4, 5. Okay, 1, minus 1, minus 2, minus 3, minus 4. This is the x-axis, and next to y-axis values are 1, 2, 3, 4, 5, 6. Okay, and here it is minus 1, minus 2, and minus 3. Okay, now let's plot the values. When x equal to 1, y equal to 6. The first point will be here. The first point is here. Okay, when x equal to 1, y equal to 6. Next, when x equal to minus 1, y equal to 2. So when x equal to minus 1, y equal to 2. So this is the value. Okay, so we will get when x equal to minus 1, y equal to 2. Now let's join these 2 points to get the graph of this linear polynomial. Okay, so now see, this is the graph of the polynomial. Linear polynomial y equal to, or p of x is equal to 2x plus 4. Okay, now see here, at this point, this graph intersect the x-axis at this point. What is the coordinate of this point? That is y value is 0 and x value is minus 2. At which point the graph intersect, the corresponding x coordinate will be 0 of the polynomial. So minus 2 is a 0 of 2x plus 4. P of x equal to 2x plus 4. That is a very important thing we have to remember. From the graph of the polynomial, how we will be able to obtain the 0 of the polynomial is just observe or locate the point where that graph intersects the x-axis. And the corresponding x coordinate will be the 0 of the polynomial. We know that in case of linear polynomial, it is degree is 1. So it intersects only the maximum possibility to intersect x-axis at one point. Therefore, it has 1, 0. 1, 0. Clear. So this is regarding linear polynomial. Now come to the quadratic polynomial, that is ax square plus bx plus c. The shape of this graph is parabola. Its degree is 2. We know that for generally quadratic polynomial has 2 zeros. While we factorizing a quadratic polynomial, generally we used to get 2 zeros. How it is possible? Let's draw the graph of the quadratic polynomial. Listen, see here, I am going to enter a value x square minus 2 into x minus 8. Okay, what is the graph of this? Shape of the graph you can see here. Okay, this is the shape of this graph. This is actually a quadratic polynomial, x square minus 2x minus 8. Clear? So in this case the graph is a curve. Okay, and this shape is called a parabola. Clear? Okay, and it intersects the x-axis. It intersects the x-axis at 2 points. One is here and another one is here. Because of that, it has two zeros. First one is here, it is minus 2. This value of x is minus 2 and this value is 4. Clear? So this is the shape of the quadratic polynomial. And it intersects at 2 points. Clear? Because of that, it has two zeros. Clear? Now on plotting of the graph, we got that is a parabola. So in case of quadratic polynomial, we got that is, it is a curve. This curve is called a parabola. In case of quadratic, one more possibility that it can be downward. It is possible if a is less than 0, that means negative value. The example which we have taken in that graph plotting, that one is x square minus 2x minus 8. So it was actually plus the coefficient of x, that is a, was 1. Because of that, we got upward parabola. While if it is negative value, we will get a downward parabola. That is we have to remember. Okay? And it intersects at 2 points on the x-axis. That is also we noticed that. So in case of linear polynomial, degree is 1, because of that it intersects at 1 point. In case of quadratic polynomial, its degree is 2 and it intersects at 2 points. So generally we can say that given a polynomial p of x of degree n, the graph of the polynomial intersect the x-axis at most n points. Therefore, we can conclude that a polynomial p of x of degree n has at most n zeros, because those intersecting points, the x-coordinate of those intersecting points are zeros. At most, that word is very important, because not necessarily always in case of a quadratic polynomial it should have a 2 zeros. For example, suppose we got the graph of the quadratic polynomial like this. See here, this black curve, that is a curve of the quadratic polynomial, a parabola, it never intersects the x-axis. It does not intersect the x-axis. That means it does not have 0. So that's why the word at most is used here. A polynomial p of x of degree n has at most n0, that means maximum n zeros. So in case of linear polynomial, its degree is 1, so maximum number of zeros possible, that is 1. And in case of quadratic polynomial, its degree is 2 and the maximum number of zeros possible, that is 2. It can be 1, it can be no 0. Clear? And in case of cubic polynomial, we can say that its degree, the general formula of cubic polynomial is ax cube plus bx square plus cx plus d. This is the general formula of the cubic polynomial, and its degree is equal to 3, because highest power of the highest exponent of the variable is 3, and its graph will be like this generally. That is, it intersects the x-axis at 3 points. That means it has 3 zeros, because its degree is 3. But not necessarily always. Let's take another possibility, that is, I am going to draw another polynomial like this. See here, in this second graph, that is the green line, okay, you can see it intersects at only 1 point. That means it has only 1 zero. So that's why I am saying that maximum number of zeros possible in case of a polynomial of degree n is n zeros. Clear? That is very important. So this is regarding the graph of the polynomial. Very important topic. Let's take a exercise 2.1 regarding this graph of polynomial. The graph of y equal to p of x are given below. For some polynomial p of x, find the number of zeros of p of x in each case. See here, in first case, this is the graph. This black line is representing graph. So, what is the number of zeros in this case? This straight line is not intersecting x-axis, so number of zeros will be 0 because it does not intersect the x-axis. So, number of zeros will be 0. And what about this graph? This graph is intersecting at one point. That means the number of zeros is equal to 1. And what about this graph? This graph is intersecting at 3 points. So, number of zeros is equal to 3. And this graph is intersecting, that is this is the graph of quadratic polynomial because this is the parabola, okay? This shape is actually parabola. So, here number of zeros is equal to 2 because it intersects x-axis at 2 points. What about here? Here 1, 2, 3, 4. 4 points. So, degree is 4. Sorry, not a degree, number of zeros. Degree may be 4 or more than 4, that we cannot say. And here 1, 2, 3. So 3 zeros. So this is actually the graph of almost it is, I hope this is the graph of cubic polynomial. Because the shape we have discussed, it is actually graph of cubic. This is not a cubic, the option 6 and 5 are not the graph of cubic or quadratic. It is degree more than 3 by quadratic or any other higher degree polynomial. Okay, so this is the linear polynomial. This is the first option is linear one, second and third are cubic, fourth one is quadratic. These two are higher degree polynomials. Clear? So this is regarding, we need to remember how to find the number of zeros from the graph. Next topic we are going to see, that one is relationship between zeros and coefficients of the polynomial. We know that in case of quadratic polynomial, first we are going to discuss quadratic polynomial, second one is cubic polynomial. Linear polynomial is very simple. Okay. So in case of quadratic polynomial, if alpha and beta are the zeros of the quadratic polynomial, then x minus alpha and x minus beta are the factors of this polynomial. So we can generally represent this polynomial ax square plus bx plus c is equal to, let's put a constant k into x minus alpha into x minus beta, because this is the factorized form of the quadratic polynomial which we get after factorization. So we return a factors as a product of factors as the polynomial. Expand this, so we will get k into x into x. First multiply that one. So x into x, distribute it, x square minus next we will get a beta x, next minus alpha x, and last one is minus alpha into minus beta will be plus alpha beta. That is equal to k into x square minus x is common in both the terms, so take it outside. We will get a alpha plus beta into x plus alpha beta. Let's multiply this k also into inside, kx square minus k into alpha plus beta into x plus k into alpha beta. So this is ax square plus bx plus c. Now comparing the LHS and RHS we get, that is a is the coefficient of x square. So what is the coefficient of x square is here k. So we will get a is equal to k. Next b is the coefficient of x. We will get b is equal to minus k into alpha plus beta. That is b is equal to minus k into alpha plus beta, which is equal to, that implies b is equal to minus a into alpha plus beta, because k is equal to a, which we already got in the first relation. And the third term, that is c is equal to k into alpha plus beta, that is a constant term. So we get c is equal to k into alpha beta, where k is equal to a. So we can modify that one, c is equal to a into alpha beta. This is we have got. So taking this relation, we again modify that one. B divided by minus A is equal to alpha plus beta. Or we can say that minus B by A, this minus and kick into upside on numerator. So minus B by A is equal to alpha plus beta. This is the first relation we have, that is sum of the zeros, alpha plus beta, alpha and beta are the zeros, two zeros. So sum of the zeros is equal to minus B by A, that is minus of coefficient of x divided by coefficient of x square, that is A. Second, we can modify this relation that we will get C divided by A is equal to alpha beta, alpha into beta. So this is the second relation we have. Product of zeros, that is alpha into beta, is equal to C divided by A. Clear? That means product of zeros is equal to constant term, that is C divided by coefficient of x square. So it is very important to remember these two relations regarding the quadratic polynomial. This derivation is not much important, but the final formula you have to remember. Alpha plus beta is equal to minus B by A and alpha beta is equal to C by A, where A is the coefficient of x square and B is the coefficient of x. That's all. And the formula that k into x square minus alpha plus beta into x plus alpha into beta is very important formula to obtain the quadratic polynomial if the zeros or the relationship between zeros are given. Clear? So very important formula, remember this. Now let's take the relationship between zeros and coefficient of cubic polynomial. It's not the part of your syllabus for the examination, but still let's discuss that one, what it will be the case of. In case of cubic polynomial, 3 zeros possible because its degree is 3. Okay, so let's call the zeros alpha, beta, and there is gamma. This all are these Greek letters. Okay, so there are 3 zeros. Then we can write what is the general form of the cubic polynomial, that is ax cube plus bx square plus cx plus d. So in the first relation, that is a sum of zeros alpha plus beta plus gamma, there are 3 zeros, is equal to minus b by a. Same as in case of quadratic, only the difference here 3 zeros. Second relation is that sum of product of 2 zeros at a time, that means alpha into beta plus beta into gamma plus gamma into beta, that is product of 2 zeros at a time, and finding the sum will be is equal to C by A, C divided by A. And what we have to remember, that one is third one, that is product of zeros alpha into beta into gamma, product of all the zeros is equal to minus D by A. So this is the 3 relations we have to remember in case of cubic polynomial, but not part of your examination syllabus. Clear? So on the basis of, we can write that general form of the cubic polynomial in terms of zeros, that is k into x square minus alpha plus beta plus gamma into x plus alpha beta plus beta gamma plus gamma alpha plus gamma alpha into, here x cube is there, okay, x cube, here x square, here x plus alpha beta into gamma. This is the general form of the cubic polynomial in terms of the zeros. Clear? Not much important, but just remember that. Okay. But the general term of the quadratic polynomial in terms of zeros, that is very important. Now let's take some questions from exercise 2.2 to understand this one. Okay. First one is find the zeros of quadratic polynomial and verify the relationship between zeros and coefficient. I am going to take first option, that is x square minus 2x minus 8. See, on factorization we already know, so I am not going to discuss in detail. split the middle term x square minus 2 to get it 4 minus 2 into x minus 8. We will get a simplification x square minus 4x. Minus of minus 2 will be plus 2x minus 8. Separate it. We will get x into x minus 4 plus 2 into x minus 4. That implies x minus 4, take it outside, into x plus 2. So now we factorized. So that implies, put it, x minus 4 equal to 0 or x is equal to 4. Second possibility, x plus 2 is equal to 0. X plus 2 is equal to 0. So that implies we will get x equal to minus 2. So there are two zeros we have got. One is x equal to 4 and x equal to minus 2. So let alpha is equal to 4 and beta is equal to minus 2. Clear? Now we have find the zeros of this polynomial. See, the same example I have taken while we drawing the graph of quadratic polynomial. We got the same zeros from the graph itself. I think you already noticed that. Clear? Then we have to verify the relationship between zeros and coefficients. Very simple one. First find the alpha plus beta. Alpha, first relation we have to verify, that is alpha plus beta is equal to 4 plus minus 2, which is equal to 2. Now LHS of this RHS of this equation is minus b by a. So minus b by a is equal to, what is minus b by a? Minus, what is the value of b? B is equal to minus 2. So minus of minus 2 divided by, what is the value of b? A is 1, because coefficient of x square is 1 here. Minus of minus 2 is 2, so 2 divided by 2 is equal to 2. So therefore we can say that alpha plus beta is equal to minus b by a. Clear? Very simple. Next, what about the second relation, that is product of zeros? For that, alpha into beta, which is equal to, alpha is 4 into beta is equal to minus 2, which is equal to minus 8. Now see, the RHS of this alpha beta is c by a. What is C? Constant term. What is the C? Constant term, that is minus 8. So minus 8 divided by A, already we know that is 1, which is equal to minus 8. So now this second relation also we verified. Alpha beta is equal to C by A. Next I am going to take from the same question option number 4. Okay. Option number 4 is given 4u square plus 8u. This is a quadratic polynomial, but the last term, constant term, is missing, so we don't need to go for splitting the middle term to factorize it. Very simple one. 4u is common, so take it outside. 4u, factorization. 4u into u. One more u will be remain, plus here it will be 2, because 2 into 4 is 8. Now it is already factorized form, so just go for that one. So that implies 4u is equal to 0, which is therefore we can say that u is equal to 0, because 4 cannot be 0. Next one is that u plus 2 is equal to 0 or u is equal to minus 2. Never solve like this. 4u square is equal to 8 minus 8u, like that. Okay, for 8u taken to rise and minus 8u, 1u is cancelled, 4 is cancelled. Okay, you will get u is equal to minus 2. You will get only one value, but u equal to 0, and you will not get if you are going to solve like this. So always go for the proper factorization. Clear? Then relation we have to verify. For that, alpha plus beta, that alpha is equal to 0 and beta is equal to minus 2. First 0 is alpha, second 0 is beta. Then alpha plus beta is equal to 0 plus minus 2, which is equal to minus 2. What about alpha minus b by a, which is equal to, here this is the general form, we have a u square plus b u plus c. So here b is equal to 8. Okay, so minus b is 8 divided by a is 4. A is equal to 4. Okay, which is minus 8 by 4 is equal to minus 2. Similar way we can verify alpha into beta, that is second relation, that is alpha into beta is equal to, what is alpha? Alpha is equal to 0 into 2 is equal to 0. What about the right side of this equation, that is c by e? What about c? C is 0 because there is no constant term. There is no constant term, so we can write a c as 0 because 4u square plus 8u plus 0, that means constant term is 0. So that is 0 by a is 4, which is equal to 0. So that is also verified, that is alpha into beta is equal to c by a. Here alpha plus beta is equal to minus b by a. This is verified. Clear? So this is all about this question. Next question we have to discuss, that one is find a quadratic polynomial each with the given number as the sum and the product of zeros respectively. I am taking the option number 1, that option number 1 is 1 by 4 and minus 1. So the first number is actually sum of the zeros. So that means alpha plus beta is 1 by 4. And the second number is product of zeros. That is alpha into beta is equal to minus 1. We already know the general formula of quadratic polynomial in terms of zeros. That is k into x square minus alpha plus beta into x plus alpha into beta. That is equal to k value, just keep it as k itself. Substitute other values. X square minus alpha plus beta is 1 by 4. X plus alpha into beta is minus 1. That is equal to k into x square minus x by 4 minus 1. Okay, no problem. Answer is simple. Now here see, x by 4, one denominator is there. So we have to eliminate that denominator. So put k equal to 4. K equal to 4. So that implies 4 into x square minus x by 4 minus 1. 4 into x square, multiply that 4 into inside. 4 into x square is 4x square. 4 into 1 by 4 is that will be cancelled. So minus x. Minus 4 into 1 will be 4. So this is the final answer. Let's take one more option, that is option 2. In case of option 2, that is 0 and root 5. So here first number is sum of the 0, that is alpha plus beta is equal to 0. Second number is alpha into beta is equal to 0, that is root 5. So the general form is, I am going to directly take here, okay, substitute here. So we will get a k into x square minus what is alpha plus beta, that is 0 into x plus alpha into beta is root 5. That is equal to k into x square plus 0 into x is 0, leave it, root 5. Now here there is no fraction in any of the terms, so let us put k equal to 1, we will get x square plus root 5. So the value of k you can choose according to the final step. That is, if that final step involves any particular fraction like x by 4, then put that value as k to eliminate that fraction. Otherwise put k equal to 1, so you will get the answer. Clear? So this is all about the first part. In the next part, I will discuss the division algorithm in detail manner. Actually, I did not discuss much about this basic ideas of the polynomials because that's all the concept you have already learned in class. But still, if you have any queries regarding that one, you can ask. And remember, regarding the graph of polynomial, only you have to remember how to draw the graph of linear polynomial. That is very easy. Regarding the other types of polynomials, you don't need to know how to draw the graph. You just need to know only how to find the number of zeros from the graph. Clear? And identify the type of the graph. Okay? So that's all about today, and thanks for watching.